Hello and welcome, young learners. This is me, Tamjid Al Islam. Welcome back to my channel for A-level physics chemistry solution. So today I'll be discussing about basic chemistry. All right. So today I'll be starting off with basic chemistry. This is a very basic of all chemistries, and this is being taught in IGCSE or O levels in your curriculum, like that way. So today I'll be discussing about what is in the syllabus and how will you take the exams, and especially I will cover up in this video about all the stuff related to basic chemistry. Okay, so let's get started. In O levels chemistry or IGCSE chemistry, you have overall in total of 4 units that concludes 29 chapters. I think the first unit consists of 10 chapters, mostly related to the basic of chemistry, the mole calculations and others. Let me just show you that one. Yeah, this is your textbook that you need to follow. So let me just show you again here. Okay, so this is the textbook that you need to follow for your syllabus. So if I go to this one, you'll see that you have a total of 10 chapters in unit 1, starting from states of matter to electrolysis. These are the 10 chapters that you have in unit 1. And in the first 4 chapters are the basics of chemistry that I'll be covering up in this one. And I will be talking about these topics later on in detail, okay? And there are 2 topics related to calculations, and there are 3 topics related to bonding. And the final one is electrolysis. Unit 2 is a different set of topics, a bit easier on the inorganic chemistry, and the first one, I guess, was the principles of chemistry. And in total, there is the unit 3 where we talk about physical chemistry. Physical chemistry is really important to understand the levels of energy. And then finally, the one that student hates the most, but you shouldn't be hating after I finish teaching you all, will be organic chemistry. Okay, so I'll be teaching organic chemistry in the very end. All right, so let's get back to our basic notes. Okay, so let's get started. Okay, so guys, as I talked about this earlier on, let me just introduce you with some basic things so that I can cover it up real quick and you just get an idea overall of what is there and what is not. Okay, so mainly I'll be covering up the chapter 3 and 4 of unit 1 in this basic chemistry mostly, and maybe at times maybe chapter 1 or 2 may come up, but I'll be discussing about these topics later on, in more details. But this is the very basic class. And yes, another thing to recall that you will have 2 papers in your IGCSE examination, where the paper 1 will consist of 110 marks and the paper 2 will consist of 70 marks, a total of 180 mark exam. You will have a grading system from 1 to 9, you know it better. So let's get started. First of all, we need to understand when you enter in chemistry in class 6, class 7, or maybe in O levels, you need to understand what is an atom. Okay, so without getting into the first definition of an atom, let's first get into what is actually an atom and let's visualize it. So this is one of my suggestions, that you don't memorize things up, especially in chemistry, physics, and even other subjects as well. You just try to understand what is there and what is not, and then later on figure out, and things will fall up into your brain. Okay, so first of all, let me show what is an atom. An atom is basically consisting of a nucleus. There is center and there is a nucleus in the center, where it mainly consists of protons and neutrons. Okay, so mainly the consists of protons and neutrons. Then we can talk about what are the other things. There is an electron outside, which is called a shell. So whenever I talk about a shell coming up where the electrons orbit, so there are mainly 3 things that you need to talk about inside an atom. One is a proton, the other one is a neutron, and the last one is an electron. Okay, so the proton and neutron will always be inside the nucleus. All right, the proton and neutron will always be inside the nucleus, and the electron will always be in a shell. Okay, the electrons will always be in a shell that will orbit around the nucleus. Now, proton is something that is a positively charged particle. All right, so let me just write this down. Proton, it will still be written later on. Proton is always be a positively charged particle, whereas neutron will always be neutral. You know, neutron coming from neutral, and this electron will be something called a negatively charged particle. Okay, so as you always know that positive and negative attract each other. So proton and electron will attract each other. That's the reason why electron will move around the proton and neutron or around the nucleus. So electron will move while remaining in a shell, and proton and neutron will be inside the nucleus. Now, this is the overall structure of an atom. Now, what actually atom is? We talked about the structure of an atom, and this is a very common question in the IGCSE. So in the paper, so I'll be talking about the atom, exactly what atom is. Remember that atom is the smallest part of an element which is completely made up of protons, electrons, and neutrons. I repeat it once again that atom is the smallest part of an element. Any element that you can think of. I'll talk about element later on, but it is the smallest part of an element which is made up of protons, electrons, and neutrons. All right. Now let's talk about subatomic particles. So whenever I talk about subatomic particles, there are three things that comes up. I told you earlier that they are the three things. These are the subatomic particles. They are proton, electron, and neutron. These are the main things that we talk about inside an atom. Now I also told you earlier that there are some things that where they exist and where they are in and what their charge and size is. So whenever I talk about proton, they have a relative charge of +1 and they are inside the nucleus, or you could say exactly at the center of the atom inside the nucleus. Whereas on the other hand, if I talk about neutron, has a charge of 1 and it's also inside the nucleus. Whereas on the other hand, electron has a relative charge of -1 and it is in orbit or in shells, whatever you talk about. Okay, so lastly, if I talk about the relative mass, this is one of the most important things that students don't get. But if I talk about this one, proton and neutron almost have the same mass, or I could say the same mass in consideration of IGCSE. So, these two have the same mass. Whereas electron has the mass of almost the 2,000 times less than the mass of a proton, or I could say it's the 1/186 the mass of a proton. Okay, so this electron is a much smaller than comparatively with proton and neutron. Now let's get to what is the nucleus. There are all definitions given up. I guess you guys can pause the video and take a screenshot whenever required. So if I talk about a nucleus is always at the center of an atom, which is positively charged due to the presence of protons. Okay, now if I talk about this center, let's say there are 2 protons and 1 neutron. A proton has a charge of +1, whereas a neutron has a charge of 0, right? So if a neutron has a charge of 0, +1 charge will make it a +2, and this is 0. So the overall charge, is +2, if I'm taking it right. So overall charge will be +2, and the nucleus will always be positively charged, isn't it? So if the nucleus is always positively charged, then I can easily say that due to the presence of protons, it is the center of an atom which is positively charged due to the presence of protons. Only positively charged particles inside the atom. Okay, so it is the center of an atom which is positively charged due to the presence of protons. I guess you are getting it right. Now let's talk about proton. What is a proton? Proton is a positively charged particle. Basically, proton does decide which element it is. Okay, because proton number is directly connected to the atomic number. Now, guys, let's discuss what is exactly an atomic number. So, if I'm not wrong, yes. So let's talk about first of all about an element. What is an element? Let's talk about an element. Then I'll be teaching you what is an atomic number. So, an element is basically a substance made up of only one type of atom that contains the same number of protons. Okay, so a substance that is made up of one type of atom and contains the same number of protons. All elements have different number of protons. Those who have different number of protons will be considered as a different element. Nothing more than that. Now let's talk about carbon. carbon has two numbers in it. If I go to the periodic table, this is your periodic table. This will be given in your exam. All right. So let's just talk about carbon here. So you will see there are two numbers for carbon. One is 12 and the other one is 6. Okay. The 12 is called the mass number and the 6 is the atomic number. The 6 represents the proton number as well. And the 6 also represents the electron number in case of an atom. But when it comes to the 12 is the total summation of the proton number and the neutron number. Let me just explain it to you a bit more clearly. Let's consider lithium in this case. Lithium has an atomic number of 3. So, lithium has an atomic number of 3, proton number of 3, electron number of 3. Okay, so total of proton number, atomic number of 3, proton number of 3, and electron number of 3. Whereas on the other hand, a neutron has always the number of the total of a mass number and atomic number. Let me just tell you in a bit more clearly. Let's say mass number is equals to proton number plus neutron number. Okay, so proton number plus neutron number. This is the total summation of a mass number. Let's just move on and make mass number the subject. If I make mass number neutron number the subject, then I can easily calculate the mass number. All right, so let me just move on to the next one. Okay. Now, substance made up of one type of atoms only that contains the same number of protons. They all have the same number of protons, as I told earlier. And whenever I talk about carbon, carbon is 12, 6. So it has a proton number of 6, electron number of 6, and then finally neutron number of 6. Okay, so as I told earlier, how did you get the neutron number 6? By subtracting it from 12 minus 6, and then you will get 6. On the other hand, oxygen has the same thing. They all have 8 because atomic number is 8, proton number is 8, electron number is 8, and a neutron number is also 8. Whereas if I talk about other elements, 16 minus 8 will be 8. Whereas if I talk about fluorine, fluorine will have a proton number of 9, electron number have 9, and there might be a mass number, whereas 19 minus 9 will be neutron will be 10. Okay, so the neon will have a proton number of 10, electron number of 10, and maybe a neutron number of 10, or maybe like this should surely have a neutron number of 10. 20 minus 10 will give you 10. Whereas boron will follow the same thing, proton number of 5, electron number of 5, and then a neutron number of a total of 6, I guess. Yes, 11 minus 5 will give you 6. Neutron will also have the same 7, 7, 7, and calcium will have all 20, 20, 20, because 40 minus 20 will give you 20. So I hope you are getting it clearly right that getting 20 here does mean that this will give you 20, and this will also give you 20, and subtracting them will give you a total of 20, isn't it? Okay. So I hope these things are clear for you. Now let's move on to something really interesting and important, that is, what is a molecule? A molecule, I hope up to this it's clear. Let's move on to the next one. Okay, so let's move on to a molecule. Smallest particle of a substance that can have a separate independent existence. Something that is completely separate from one another, that can exist freely, or that can exist randomly. That is a molecule. I told you about mass number earlier, that is the total number of particles in a nucleus. Let's say, for example, there are 40, the mass number is 40, so a total of 40 20 protons and 20 neutrons are there. So that is what it tells about the mass number. Now, if I talk about electron number, it is the lightest subatomic particle. As I told you earlier, it has a mass of 1 by 186 of the total mass. So I could say it is the lightest subatomic particle which spins around the nucleus, is negatively charged, so it exists in the cells. slash orbit. So there are three main important, or I should say four main important definitions related to electron, or four main points, I could say. If you write down in separate points, that will be really great for you, as I didn't write it. It is, first of all, it's the lightest subatomic particles. It is spin around the nucleus. It is a negatively charged particle, so it exists in the orbits or shells, and that's it. This is the smallest of all. It is spin. It is negatively charged particle, and it exists in orbit. Now let's move on to another thing, that there is attraction between proton and electron, and that attraction is known as the electrostatic force of attraction between proton and electron. The force of attraction between oppositely charged particles, such as positively charged particle and negatively charged particle, is known as the electrostatic force of attraction. As I told you earlier, the atomic number, proton number, and electron number will be equal. They are all the same thing, and they will contain equal number of proton and neutron when there is an overall charge of 0. Now, here is another important concept that will come up in the next topic, that is charge. I'll be talking about charge later on in this topic. Charge is a really important concept to understand what exactly they are talking about. So if you clearly focus on this one, let me just show you. Let's follow. Let's say for example, you have this symbol as your thing. So the symbol talks about S. Sorry, there is S. S talk about the symbol. A is the atomic number. M is the mass number. C plus is the charge, and N is the number of atoms. Okay, so this is all the things that you need to understand about an element. All right, now let's talk about arrangement of electrons and how they can be shared. All right, so before okay, so as I was discussing, so let me talk about charge right now. This is a really important concept. Now, what is charge exactly? When an atom loses or gains electrons, it becomes charged. Okay, so whenever it loses or gains electrons, it becomes charged. It can either be negatively charged or it can either be positively charged. Now, let me just give you a basic that if someone loses something, maybe gives away or loses electrons, it becomes positively charged. And whenever they gain an electron, they become negatively charged. Gaining electrons from someone, taking away electrons from someone is a bad thing. That's why they are referred as negative. And giving away something to someone is a positive job or a positive action. So that is why losing electron makes it a positively charged particle. Now, let's come to a concept where I'll be talking about the periodic table. Understanding the periodic table is quite important. Let me just talk about, first of all, I have already told you about the symbols, the atomic number, and the proton number, and the mass number, overall everything. And let me just introduce you that there are 8 groups, which is known as the vertical columns. These are the vertical columns, these are the vertical columns, these are the vertical columns. And there are 7 periods, 1, 2, 3, 4, 5, 6, 7. There are 7 periods. Okay. So I hope you are getting what I'm talking about. Now, if I talk about the chart, listen very carefully. If I talk about the charge, this group all the elements of this group have a tendency of forming a charge of +1, and they have a tendency of giving 1 electrons away. Okay. Now, why do they give 1 electrons away? I'll be giving you the reason a little bit later. But just remember, everything of group 1 gives 1 electron away, so they form a charge of +1. If I talk about group 2, they have a charge of +2, so as they give away 2 electrons. If I talk about group 3, now this is group 3. Be careful about the group. This is group 3. They always give away the charge. They will always give away 3 electrons, and they will form a charge of +3. Group 4 can either have a charge of 4 plus, it means they can give away 4 electrons, or they can even gain 4 electrons, so they have a charge of 4 minus. On the other hand, group 5 can have a charge of 5 plus. This means that they can give away 5 electrons, or they can have a charge of 3 minus, where they will gain 3 electrons. And group 6 can either form 4 plus, 6 plus, or 2 minus. Plus means that will give away, and 2 minus means they will gain. And group 7 will be 1 minus, which means they will just gain 1 electron, or they can gain only 1 electron. Whereas on the other hand, group 0, or you can call it as group 8, they don't have any charge, neither they react with something, they are all gases. Okay. Now, people might ask me about the charges of this, this middle portion. I'll be discussing about this a little bit later, because this group, this D block is known as transition metals. This is a D block element, and they have a various number of charges. So I'll be talking about this later, and they do not follow a pattern. They have different charges. Now, let me just give you the reason why group 1, lose 1 electron, why group 2 loses 2 electrons, why group 3 loses 3 electrons, and group 4, and blah, blah, blah. So, especially in IGCSE, you will get to learn that, let's talk about hydrogen. Hydrogen has a charge of +1, hydrogen can form a charge of +1, and hydrogen has 1 electron in its outermost shell. Why? Because it has an atomic number of 1, so that means it will have only 1 electron in its outermost shell. Helium will have 2, lithium will have 3. Now, remember that there can be shells being formed. Okay, so this is known as the arrangement of electrons inside an atom or cell. Electrons in the first cell, let me just introduce you with this one. This is the first cell. Okay, this is the first cell, and this is my second cell. Now, there can be a total of 2 electrons in the first cell, maximum of 2 electrons, and the second cell can carry up to 8 electrons. Whereas, on the other hand, the third cell can take up to 18 electrons, but we'll talk about this later on. Beryllium has 2, so the inside cell will have 2, and the outer cell will also have 2. This will have 2, 3. So boron will have 2 maximum, and the 3 outside cell or the outer cell. So 2 will be the inside cell, and there will be 4 electrons in the outermost cell. There will be 2 electrons in the inner shell, and there will be 5 in the outer shell for nitrogen, and then oxygen will have 2 electrons in this inner shell, and probably 6 electrons in the outermost shell. And this is how they follow. Now, if I talk about sodium, sodium has a total of 11 electrons. So the first one will have 2, the second one will have 8, and the last one will have 1. Whereas on the other hand, silicon will have 2, 8, 4, because it has 14, so 2, 8 will give up 10, and then 4 will give 14. Now here a little bit of example. Now I'll be showing you why they follow the way of losing 1 electron. Let me just give you a similarity. Let's talk about hydrogen. Hydrogen has only 1 electron in its outermost shell, correct? In its outermost shell. Remember my statement, in its outermost shell. Now let's talk about sodium. Let's first of all talk about lithium. Lithium has 1 electron in its outermost shell, correct? Now, if I go to sodium, sodium will have another electron in its outermost shell. Now, if you look at it very carefully, losing 1 electron is better than gaining 7, because it requires a lot of energy to gain electron and to lose electron as well. But if it is capable to become a a full cell. The idea is to become a full cell. Every element, whenever it is in an atom state, it wants to become charged in order to become stable. Now, this is a very important concept that students don't get it, that why they lose electrons, why they gain electrons. But the main thing is that you lose electrons to become stable, or you gain electrons to become stable. The main idea to become stable is to have a full outer shell. Stability stability is always related to full outer shell. Okay, if you have a full outer shell, that means yeah, you are stable. That can be either in the form of 2, it can be 8, and up to 2 and 8 you have in your syllabus. 18 is not in your syllabus because in IGCSE we don't talk about 18. All right, so this is the key thing that you need to understand why they lose one electron. Now, if I talk about all the group 2 elements like beryllium, if you consider beryllium will have 2 electrons in its outermost shell, and on the other hand, magnesium will also have 2 electrons in its outermost shell. So, if magnesium has 2 electrons, that means that they will lose 2 electrons. This is how things are being formed. Now, if we look at fluorine has only 1 electron remaining to become a full outer shell. It is left with just 1 electron, so it will gain 1 electron to become full outer shell and in order to become stable. All right, so I hope this is getting a bit more clearer. Now let's move on to periodic table. I have already talked about periodic table. Periodic table follows an arrangement where the atomic number increases. I've already showed you this one, and there is 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. And the ones where similar chemical properties are placed in the same group. Period will have horizontal rows and group will have vertical columns. Okay, period are known as horizontal rows, groups are known as vertical columns. There are 7 horizontal rows and 8 vertical columns. Valence shell number, period number, valence electron number, group number. These are all important to understand. Now, what is a valence shell? It is the outermost shell of an electronic configuration. What is a valence electron? Total number of electrons in the outermost shell is valence electron. Now, if I talk about electronic configuration, it is 281 of sodium. Okay, so the first shell will contain 2 electrons, the second shell will contain 8 electrons, and the third shell will contain just 1 electron. And let me just remind you one thing, that sodium is in group 1, right? Sodium is in group 1. That's why it has only 1 electron in its outermost shell. And if you remember that sodium has 3 periods, sorry, does not have 3 periods, it is in the 3rd period. If you look at this one, this is the 3rd period. See, sodium. Now, if I go back to what I'm talking about, that in total there are 3 periods, or I could say they're in the 3rd period, right? Sodium has 3 outer shells, so I could say they have 3 shells. So the shell number decides the period number, and the outer electron number decides the group number. Let me just give you an example. Let's say nitrogen have two shells, right? Valence shell is 2, so they have a period number of 2. Now, valence electron, whenever I talk about the outer electron number, they have 5. The group number is definitely 5. Okay. Now, if I talk about valence shell, whereas there is 3. So in total, there are 3 valence cells, and there are a period of 3, because sulfur has 3 valence cells, and they are in a period of 3, whereas valence electron will be 6, and the group will be 6. I hope you are getting all these things. If an atom has 8 electrons in its outermost shell, it will belong to group 0, definitely 100%. It will belong to what group is called group 0, okay? I hope you're getting it. Stability of a shell. A shell can become stable if it is completely filled with electrons completely. A shell can become stable if it has 8 electrons. Okay, so a set of 8 electrons. So a cell can become full if it is completely filled with, it can become full if it is completely with electrons. A cell can become stable if it has 8 electrons in its atomic cell. As I told you earlier, of the form of set, or I could say a full set of electrons. All right. So let's just move on to the next one. If the overall charge of a group of atoms is zero, the group of atoms is said to be a molecule if they have a charge of what? If they have a charge of zero. All right. If they have a charge of zero, they are said to be a molecule. And a molecule is a solid particle that can have a separate existence again. There can be molecule of element and molecules of compound. If you talk about molecule of element, where there will be only one type of element. Now, if you guys ask me what is a compound, then I could say I'll be discussing about this in the later topics, in the topics 1 and 2. But combination of an element is called a compound. Okay, so hydrogen, oxygen, nitrogen. These are all elements, but molecules in the form of molecules, and they are compounds because they have two different molecules or two different elements sitting up. Now there are specific differences such as what is known as a monatomic gas. It is known as a monatomic gas. The one that consists of helium, neon, argon, krypton, xenon, and radon are all monatomic gases. And the atomic molecule keep also see. So the idea is that a molecule that contains two atoms, the atomic gases, that is hydrogen, oxygen, nitrogen, chlorine, bromine, and iodine, are the atomic molecules. Okay, di means two. If you look at there are all twos around, and if you talk about monatomic, then they are just single, they're one. Okay, so let's move on to the next one. I hope these are getting clear. Now let's talk about radical. Radical means can be divided into two parts. It has positive radical, and the other one could be a negative radical. A group of atoms can either be positive or negative, which behaves like a single atom in a chemical reaction. Let's say, for example, ammonium ion. That is a positively charged radical. This is a negatively charged radical. These are all negatively charged radicals, and this is a positively charged radical. On the other hand, if you want to understand what is the difference between a radical and an ion, a radical is always formed when it is break down into parts, but an ion is always formed when it loses or gains electrons. That's what I was talking about a lot earlier in the very beginning. Okay, so ions are the ones when two atoms gain or loses electrons, it becomes electrically charged. That is known as an ion. It has two types, a positive ion and negative ion. Positive comes from cations. Positive is known as cations and negative ions is known as anions. My chemistry teacher taught me this one, so I'll be teaching you this, that, a very small mnemonic to remember this, so that cat comes from pussy. So pussy cat, this is a much funnier one. P and P, the same thing. So, positive ions are cations and antis are always negative. So they are known as anions, they sound similar. So very, lame mnemonic, but, you can remember this. When the proton number of an atom is not equal to the electron number, it is no more neutral, it becomes an ion. I hope I have told you this one earlier, that this note is really important, that when the proton number and the electron number is not equal anymore, they are not considered to be a neutral atom anymore. Now let's talk about the formation of a positive ion. When an atom loses or gains electron, it becomes positive. Okay. When an atom loses electron, it becomes positively charged. Now metals always form positive ions or cations. Now, if I talk about which are metals, this will be a very hard, big topic to understand that which are exactly metals, because I'll be discussing the metals regardless. So there is staircase line which shows that there are non-metals and there are metals and there are some semi-metals as well. If I show you which are the metals, the staircase line will start from here somewhere. Okay, so it will be going like this. I'll be showing you this one in the later topics, but if you want, now, this is something that is, everything towards the left is metals, and, things that are right to it are non-metals. There are some things called known as a semi-metal, but I won't be talking about these things because this is way too, advanced in terms of IGCSE. And you can also remember one thing, that the most name that ends with IUM, IUM, that is metals, and the ones that are not ending with IUM are mostly non-metals. Okay, so let me just get to what is there. So when an atom loses an electron, it becomes positively charged ions. Metals always form positive ions, and when an atom becomes positive ion, its name remains the same. Okay, let's say sodium. With sodium, after losing their first electron, they become sodium plus, sodium 11, and then become sodium plus 2A. So they become positively charged, and their one electron is lost. So, they become sodium ion. Whereas on the other hand, formation of a negative ion is when they gain one electron and they become negatively charged. Non-metal usually form negative ions. And whenever they form negative ions, their name ends with IDE or I. Let's say, for example, chlorine is 2H7. Whenever they gain one electron, they become, they gain one electron, so they become 2H8. They have overall negative charge. You have to draw like this. This is a very common diagram that will be coming up in your syllabus. And you can use dot, cross, or circle to, explain your electrons. And this becomes fluoride ion. Okay, so this is the thing. Now, if you talk about the valency chart, this is a very common valency chart. I think you can use this one to memorize and to understand some common questions. Like all this one have positive charge of +1. +2 charge will be the group 2's one, and lead and tin have +2. Group 3 have +3. Group 4 have +4 mostly, and group 5 have +5. Group 6 and some other compounds will have +6. All these group 7 will have -1. Some will have -2, and nitrogen will have -3. Carbon will have -4. And now if I talk about the transition metal charges, so let me just go back to transition metal charges in the periodic table right over here. So mostly we'll see after the group 2, there is a group of scandium and yttrium that will be consisting of group of charges of +3. Then the other one will mostly have charge 4, they will have 5. And the sixth one will have 6 plus, and sometimes they might have 3 plus. This one will have 4 plus and 2 plus. And all the rest will have 2 plus, except I think still copper will have +1, silver will also have +1, and gold will have +1 and +3, I reckon. Okay, or I could say it will have +3 only. So this will be given to you mostly, but it will be really helpful for you to remember all these charts. Copper, silver, gold, +1. Copper, iron, mercury, manganese have +2. Scandium, iron, chromium, gold will have +3. Manganese and titanium +4. Vanadium will have +5. Okay, so and mostly chromium and manganese will have +6 charges. Now, another thing that I need to make you recall that group 6 is something that consists of 3 charges, and it's really difficult to understand which charge is what. But I have given you a very, very important statement over here that oxygen will always have -2 charge. Okay, no matter what, oxygen will always consist of a charge of -2. I think this won't take you away because this will help you to identify the charge of other cations. Okay, so let's see some examples. Let's talk about ammonium ion. This one has overall charge of +1. We don't know what is the charge of nitrogen, but we know what is the charge of hydrogen. Hydrogen has a charge of +4. Which means that See nitrogen, the charge of -3, right? Now, on the other hand, if we talk about this one, we know oxygen has a charge of -2, and the overall charge is +1. So I've written 1 over here, and the total hydrogen has 3x minus 2 is equals to 1. So it's 3 by 3, and x is 1. OH minus -2, and x is unknown. Let's make x subject and use to identify. Now you will ask me, a lot of you will ask me that hydrogen have a charge of +1. We know that, but not in the case of hydride. And the charge of hydrogen may vary from +1 to -1 depending on whether it forms a hydride or it forms a hydrogen ion. Okay, so if I talk about NO3 minus, in this case, there are a total charge of 6 minus, and this is a -1. So X will have a charge of +5. NO2 minus, let's say this will be 2 minus, and this will become X is equals to +3. Okay, so this is how we will be, the overall charge will be -1. I will make X the subject of this. I think this was a test that I was conducting for the bad student. Okay, so sulfate ion is X plus 4 minus 2 minus 2 X, the value of X is 6. Now, if I talk about this one, you will see that as I told you earlier, that oxygen will always have a charge of -2. Okay, so it will always have a charge of -2. That will depend on X will have overall value of 4, whereas carbonate will become 3 and -2, and the overall charge is -2, so X value will be +4. I hope this is how we'll identify. And if you see, there is a complex compound of 3 elements. Hydrogen charge has +1, oxygen has -2, so 1 and -6 will end up being 6. So carbon will produce a value of charge of value of 6. So the one that are fixed, you will use that one. You know the overall charge, you will use that one and make X the subject and to identify what is there and what is not. So we are almost ending the concept. This is the last part, and I think it takes me a bit of 50 minutes or 55 minutes to complete this basic chemistry topic. That what is an isotope? This is the last thing. That isotope is basically, if you talk about isotope, it is the same element, it's same atomic number, but different mass number. I'll be discussing about, but there is a very common definition of an isotope, and believe me, this definition will definitely come up in your examination, in your O-level chemistry, in your O-level physics, and in your even AS and SO as well. This is a very common definition. That in terms of subatomic particles, that they have the same number of protons and different number of neutrons. I know you may not remember this one easily, but let me just give you some examples that will help you. Let's say hydrogen. Hydrogen will have 1 proton, 1 electron, and 0 neutron, right? If you get it right. Now, hydrogen has an isotope known as deuterium, which will have different number of mass number from hydrogen, different number of neutrons. How? Proton same number, electron same number, but neutron number is 1. If I talk about tritium, this is another isotope of hydrogen. We'll have 1 proton, 1 electron, and 2 neutrons. But the proton and electron number are the same in case of this. Now, here are 3 things. It depends on the total number of electrons and its electronic configuration. Isotopes have same chemical properties, identical chemical properties, as the same number of electrons and electronic configuration. Okay, so they will all have the same number of electrons. Number 1, same number of electrons, same electronic configuration. They will have similar chemical properties, identical chemical reactions, same number of electronic configuration. Isotopes have different physical properties such as density and rate of diffusion, because isotopes differ in mass. So their physical properties will be a bit different, and they will have different rates of diffusion. Okay, so let's move on to chlorine, the isotope. Now, chlorine isotope have a very important calculation question that will come up in your exam, such as chlorine has 2 isotopes mainly, chlorine 35 and chlorine 37. Chlorine 35 is 75% in the nature, and chlorine 37 is 25% in the nature. And they will ask you to calculate the relative atomic mass. Relative atomic mass is the average mass of atoms. So if I consider this, I will be multiplying 35 with 75. and then 37 with 25, and then divided by 75 plus 25, which will give me 35.5. Now, interestingly, uh, if you go to the periodic table, let's say over here, the chlorine will have the mass number of 35.5. This is how they identify exactly what mass number an atom can have. Remembering the percentage of an atom and how they will be there. Okay, so that is it. And yes, similarly on the other hand, if I talk about boron, let's say boron 10 is 20% and boron 11 is 80%. Now, if you make it account, you'll take 20 multiplied by 10 plus 80 multiplied by 11, you have 100, and that will give you 10.8. Okay, so 10.8 is almost similar. Remember that if it's 10.5 or something that is 0.5, you will write that as 0.5. But if it's 0.4, then you can write it as 10. Even if it's 0.6, you can write it as 11. This is how it works. And boron and bromine has 79 and 81. Carbon has 3 isotopes, 12, 13, 14. And carbon has overall 3 isotopes, carbon 12, 13, 14. And 13 and 14 are all radioactive isotopes. All right, I hope you got what isotopes actually are. Now, let me just finish it off with some important things that you may remember and that you will find much more enjoyable to understand what exactly we are talking about. That is this. That is classification of elements. There are 3 types of elements: metal, non-metal, and semi-metal, and they can also exist in 3 sets of matter, which will be the first topic and the second topic that we'll be discussing, or maybe the first chapter of chemistry: solid, liquid, gas. So if I talk about liquid, there are only 2 liquids in the periodic table, that's mercury and bromine, and gases are all the group A gases. These gases, all these gases are all gases and noble gases. Chlorine, oxygen, nitrogen, and hydrogen at times are all gases. Okay, and and solid, most of them are solid, and almost you see, which I have marked as pink color. You can see pink color is mostly metals, and the one those are yellow are non-metals. And if you want to know the name of the group, the first group is known as alkali metals, and the second group is known as alkyl and earth metals. The third group is known, that does not have a name. Group 7 is known as halogens, and group 8 or group 0 is known as noble gases. Okay, and the middle part is known as D block elements or transition metals. They have variable color and they have variable charges. And these are also, these are still different elements. You don't have to talk about this one in your O levels or IGCSE. And guys, that basically concludes the story of our basics of chemistry. I hope I have cleared everything or covered everything related to the basics. There will be some in-depth idea about these topics in the tests of matter. In the tests of matter, elements and compounds, and furthermore about charges and how they work. So if I give you a summary about all this thing, then we talked about the atom, what is exactly an atom is. First we have the syllabus, which is for the syllabus and e-papers. Then we talked what about an atom is. Then we talked about the charges and where they are currently located. Then we talked about nucleus, how they are positively charged, the proton, and how the charges goes on. Then we talked about how to identify the neutron number, mass number, atomic number, proton number, and electron number. We talked about molecule, we talked about the mass number, and then we talked about the electron number. Electron number is nothing but the lightest subatomic particle. Then we figured out what electrostatic force of attraction is. And then we discussed about the symbols, atomic number, mass number, first cell, second cell, third cell, fourth cell. Electronic configuration is quite important to understand that how they build up, where the electronic configuration. Periodic table is another thing that is really important to understand, not to memorize, because many of my students ask me that, will I memorize the periodic table or not? Then the answer is no. Practice will make you understand what periodic table is, how actual periodic table works. Then we talked about the valence shell. Remember that valence shell decides the period number. How many cells are there will decide your period number. And the valence electron, that how many electrons are there will decide your group number in the outer shell. Okay. Then I talked about how they charge up and how getting 8 electrons will make it stable. And at some cases there are 2, such as helium. Okay. And to become in order to become stable, they need a full outermost shell. Monatomic gases, diatomic gases are also there. Radical are things that can be divided, that can be split into parts. Ions are something that are really important. It's much more important than radical. That ions is about gaining and losing electrons. It's about making up electrically charged, and their diagrams will come up in the exam if you remember. And then we talked about negative ions, the valence charge, the valency charge, where we talked about to identify the charges. All right. And finally, we talked about isotopes. Isotope is another thing that you need to understand about how they work and how their chemical properties and physical properties are indifferent and same. And in the very end, I gave you a periodic table where we discussed something related to the metals, non-metals, the states of matter, and the overall idea of the periodic table. Okay, so this basically concludes the story of basic chemistry. There is nothing much more that I can talk about in basics. The other things will be advanced, and we'll get more ideas related to the other topics. And that concludes the story. So thank you very much for watching this video. I hope you have understood all of the things. If you have any question or any sort of queries, you can just ask me in the comment section. You can just write it down, or you can use my phone number, or you can text me at Tamjid Al Islam, or you can even also use my email for your purpose. And do let me know that, about which topic you want to know in the next video, because I'll be covering up all the topics related to chemistry, IGCSEs, AS and A2, and even also as physics. So thank you very much again. Do like this video if you think that this is very knowledgeable. Do share this one with your friends, family, and other relatives who are going through chemistry and have a little bit less knowledge about chemistry. And do subscribe my channel to get more videos related like this. And also don't forget to push the bell icon so that you get notified instantly when I post a video. So thanks again, and see you in the next one.